This is Deepak Kumar, Assistant Professor in Kite Group of Institution. Today we will discuss the concept of Tower of Hanoi. So this is basically an example of recursion. So now just see how can we find out the algo of this Tower of Hanoi. So in this particular problem, we have actually 3 towers, and one of these 3 towers basically contain the stack of disk in decreasing order from bottom to top. Our problem is we have to move all these disks from one tower to another tower. Let's suppose here we have total 3 towers, A, B and C, and we want to move all these disks from tower A to tower C. So for moving all these disks from one tower to another tower, we have some rule also. The rule is that we can place or we can move only one disk at a time from one tower to another tower. That is the very first rule. The second rule is that no larger disk can be placed on a smaller disk at any movement of disk. That is the second rule. That means we cannot place larger disk on a smaller disk. The third one is that only top of the disk, only top disk can be moved at a time. Okay, so we have to move the top disk. So now if you want to move all these disks from one tower to another tower, it's not an easy. So for that, here we use an auxiliary tower. So B will be considered as an auxiliary tower. By using this tower, we can be able to move all disks from one tower to another tower. Okay, so now we will generate an algo for this problem, and we choose the smaller problem, and then we will try to elaborate the algo for complex problem. Okay, so now we will start with a single disk. So let's suppose the tower A basically contain only one disk, and we want to move this disk from A to C. So this is the simplest one. Here we can directly move this disk from A to C. That follow all the rules of Tower of Hanoi problem. Now let's suppose if we have 2 disks. So how these 2 disks can be moved from tower A to tower C? Now just see, first of all, we move a disk from A to B using C. Okay, actually why we have written using C? Because we want to move all these disks from A to C. Okay, but here we choose the source and the auxiliary tower. So this tower can be used as using. So first of all, we move a disk from A to B. So this disk will be moved to B. Now we move a disk from A to C. So next we will move disk A from A to C. Then we move a disk from B to C. Actually we are not starting with the source, so that's why this source right now will be using. So here we have written using A. So now we move this disk B to C. Okay, so these three steps are basically required to move two disks from tower A to tower C, while B is a tower that is using. So with the help of these three steps, we can find out the algo for the complex problem also. Now just see, if we have three disks in a tower A, then how it will be moved from A to C. So what we do, first of all, we move the two disks from A to B using C. How can we move two disks from one tower to another tower? I explained it earlier. The previous example is for two disks. So it is very easy for us to move these two disks from one tower to another tower. So first of all, we move two disks from tower A to tower B using C. Now we move a disk from tower A to tower C. It can directly be moved. Okay, so the next step is move a disk from A to C, and we move it. Now what we have to do? Now we have to place these two disks, we have to move these two disks from tower B to tower C, and here the tower A will be using. So we move these two disks from tower B to tower C. So this is the way through which we can move three disks from one tower to another tower. So now we can elaborate the number of movements and the process for n number of disks also. So let's suppose if we have total n number of disks, so what are the steps for movement of disk from one tower to another tower? Let's see with the help of these three steps. So if we have n disks, so what we do? Actually, when we have three disks, so we move two disks from A to B using C. So if we have n disks, so what is the first step? Move n minus 1 disk from A to B using C. Because if we have three disks, so we move two disks from A to B using C. In the same way, if we have n disks, so we move n minus 1 disks from A to B using C. Now the next step is move a disk from A to C. That is similar for n number of disks also. Now the next step is move two disks from B to C using A. So if we have n disks, so what is this step? Move n minus 1 disks from B to C using A. So with the help of these three steps, we can elaborate the movement of disk from one tower to another tower, whatever the number of disks we have. So let's see the solution for n disk also. So if we have n disk, so these are three steps. Okay, n minus 1 disk move from A to B using C. Then we move a disk from A to C, and then we will move this n minus 1 disk from B to C using A. Now we will discuss the algo for this Tower of Hanoi problem if we have n number of disks. So as we elaborate these three steps by simple examples, that is if we have one disk or if we have two disks, so using these examples we can find out these 3 steps for the 3 disk also and for n disk also. Okay, so now this is the algo for the Tower of Hanoi problem. As we want to move n number of disks, so here we have n from A to C. So A is what? A is your source and C is your destination, and B tower is basically used for using. Okay, if we want to move n disk from A to C, so then B tower will be using. This is the middle one. Okay, now what is the first step? Move n minus 1 disk from A to B using C. So here we use C. So this is the middle tower, this is the source, and this one is your destination. So we check if n is greater than 0, then T Tower of Hanoi n minus 1 comma A comma C comma B, because A is the source, middle one is the using, that is we are using C, and the next one is destination, that is B your destination. Now what is the second step? Move a disk from A to C. So here we move a disk from A to C. Next what we do? Move n minus 1 disk from B to C. So B to C, B is your source, C is your destination, and A is using. So A is the middle one. Now just see, we n minus 1 disk from B, B is your source, C is your destination, and A is the middle one. Okay, so this is the algo through which we can implement the concept of Tower of Hanoi. Now we just trace the process when we have 3 disks in a particular tower. So what we do, just see over here, this is an example for 3 disks. So initially the number of disks is 3, 1 is the source, 1 actually here we just number the 3 towers. Source A will be numbered as 1, source B tower will be numbered as 2, and the C tower will be numbered as 3. Now A is 1, B is 2, and C is 3. So A is the source and C is the destination, and B is the middle one, that is using. Now what we do, when we implement this algo, then we have 2 recursions, that is Tower of Hanoi n minus 1 A comma C comma B. So Tower of Hanoi n minus 1 is what? 3 minus 1 is 2, A is 1, C is what? C is 3, and B is 2. Okay, so 2, 1, 3, comma 2. The next one is move disk from A to C. So A is 1 and C is 3. So we move disk from 1 to 3. Another recursion is that TOH n minus 1 comma B comma A comma C. So n minus 1 is what? N minus 1 is 2. B is what? B is 2 over here. So here we have 2. A is 1. So A is 1. C is 3. Okay. So when we trace these 2 recursion further, so what we do? In this particular case, A is 1, B is 3, and C is 2. So when we implement this algo over here, so what we do? The first step is TOH n minus 1 A comma C comma B. So A is 1, C is 2, and B is 3. So A, C, and B. Okay. So 1 comma 1 comma 2 comma 3, because n minus 1 is 1, 2 minus 1 is 1. Okay. Next we move this from A to C. So A is 1 and C is 2. So we move the disk from 1 to 2. The next one is n minus 1 comma b comma a comma c. So n minus 1 is what? N minus 1 is 1 because 2 minus 1 is 1. B is what? B is 3 over here. So here we place B. Then A is what? A is 1. So here we have 1. And C is what? C is 2. So we placed C, that is 2 over here. Okay. In the same way, when we expand this using the given algo, so what is the result? Let's see. The first step is n minus 1 comma a comma c comma b. So n minus 1 is what? That is 1. A, B and C in this particular case. So what is A? A is 2. What is C? C is 3. And what is B? B is 1. Okay. Now the next one is move disk from A to C. So A is what? 2 and C is 3. So here this is the movement from 2 to 3. Next one is what? N minus 1 comma B comma A comma C. So n minus 1 is 1, B is 1 over here, so B is 1, A is 2, so A is 2, and C is 3, so C is 3. Okay. Now we further expand this recursions using this algo. So when we have disk is equal to 1, so n minus 1 is what? N minus 1 is 0. So if n minus 1 is 0, that is if we have n is greater than 0, then we do nothing. Okay, so that's why here we just use this cross, because here we have one disk. So for one disk, when we perform n minus 1, so n minus 1 is 0. So this is cross. Okay, and this is basically your print statement. Okay, that is print 1 to 3, then 1 to 2, then 3 to 2, then 1 to 3, then 2 to 1, 2 to 3, and 1 to 3. Okay. So when these are nothing but these are basically the number of movements, the movements that we perform for moving 3 disks from one tower to another tower. Okay, so this is basically the tracing when we use 3 disks in Tower of Hanoi problem. So let's see these movements will be helpful or not. So what are the movements? The movements are 1 to 3, then 1 to 2, then 3 to 2, then 1 to 3, then 2 to 1, then 2 to 3, and then 1 to 3. Okay, so these are the movements through which we can place 3 disks from one tower to another tower. Now just see it is helpful or not. So what we do, first of all, we move a disk from 1 to 3. Okay, so from 1 to 3. So as we know that the top disk can only be moved, so this top disk will be moved from 1 to 3. Okay, now the next one is 1 to 2. So we just move the top disk from 1 to 2. Okay, so the top disk will be moved over here. The next one is 3 to 2. So we just move this disk from tower 3 to tower 2. Next one is 1 to 3. So we just move this disk from tower 1 to tower 3. Next one is 2 to 1. So we move this disk 3 to tower 1. Now 2 to 3. So we move this in tower 3. This one. Now the last one is 1 to 3. So we will move this disk from tower 1 to tower 3. Okay, so in tracing we just find out these steps, these movements: 1 to 3, 1 to 2, 3 to 2, 1 to 3, 2 to 1, 2 to 3, and 1 to 3. So when we performing these movements, then we placed all the 3 disks from tower 1 to tower 3. Okay, so this is the tracing of 3 disks in Tower of Hanoi problem. Now just see how can we find out the number of movements, or we can say that the complexity for Tower of Hanoi problem. So let's suppose Mn is the number of moves to transfer n disks from one tower to another tower. So when we want to transfer n disks from one tower to another tower, so we generally use 3 steps. First of all, we move n minus 1 disk from A to B using C. Okay, so when we move n minus 1 disks, so here what is the recurrence? The recurrence is that m of n minus 1. In the next step, we move a disk from A to C. So only one movement is required. So here we directly written is 1. The next one is we move n minus 1 disk from B to C using A. So here the total number of movement is n minus 1. So here m of n minus 1. Okay. So here the mn is equal to 2 times m of n minus 1 plus 1. And we know that if we have one disk, so only one movement is required. So m1 is equal to 1. So when we solve this recurrence relation, then we find out the total number of movements for transferring n disk from one tower to another tower is 2 की power n minus 1. 2 की power n minus 1. So where n is the number of disks. So this is the way through which we can calculate the number of movements when we move n disk from one tower to another tower. Okay, so in our previous example, I just show you that when we want to transfer or move 3 disks from tower 1 to tower 3, so total 7 moves are required. 1 to 3, 1 to 2, 3 to 2, 1 to 3, 2 to 1, 2 to 3 and 1 to 3. So total 7 movements are required. So if we have 3 disks, so what is the total number of movements? That is 2 की power 3 minus 1. 2 की power 3 is 8, minus 1 is 7. So 7 movements are required. So this is the way we can find out the number of movements in Tower of Hanoi problem. I think this concept is very clear to you. Now we will meet in our next video. Thank you so much.